Yeah, hello. My name is YichenHan and my student number is 21672320. Now let's go through our codes. First, we download the data site. Okay, the text one is the word class. This is really similar as the one we made in assignment part one. Something to mention is that we also initially make neighbors a set, not a list, because we want to avoid duplicates. And after we saw the neighbors, we make it back to the list. Okay, the add frequent method, the find neighbor method, if the difference in letter zero, they are neighbors, and the add neighbor method, and the sort neighbor method, and the sorting function we can choose. Okay, and this method is used to directly compare the order of the word object. And this method, just the two string method, is just a display. Okay, and now for the text two, uh, I choose to use a hash table with separate chaining. And in assignment part one, I use a dictionary. Dictionary is a key value pair, and hash table is a key value pair. Kind of like the structure, I think they're really similar. So I use hash table, and with separate chaining, like I thought, if we may under like a large collisions, the separate chaining will give us a really good efficiency and a really stable performance. Okay, and first for the class we made, I first we make a size a really really large prime number. Yeah, because this is a common technique in hash table implementations. And now for the constructor, like we initialize the hash table with this number of buckets, and each bucket is an empty list, which will hold word objects that we need to like hash to that index. And it supports separate training because like multiple items can exist in the same bucket at the same time. Okay, now the get hash value method. This value is for get a final index of where to store the key in the table. It's when we need to like insert it or create a new one of it. Okay, we make hash value to 0, and we make all character in the element key. We use this odd method to convert each character to its Unicode, and we use hash value to plus it here, and then we just get the hash value, get the key. And then the insertion method. The insertion method is also first we use the get hash value method. We just used to find the key, and then we use this key and as the index to get a bucket, and then we make a loop here. Like if the old word object is already in the bucket, then we add frequency. If not, we just create new one, add the word to the bucket. Okay. And the search method. The search method is just first we also get a hash value, get a bucket with a loop. If they are equal, then we just get what we want. Okay, it's now the get all words method. It's just used to collect all word object in the entire table. We just make a loop, erase through each bucket, and add the contents to a single list, and then we return this list. That's what we need. And I also read the test method for the class we just made. We can see there. Here are the words we want to insert. And we can see we have three apples, two bananas, one grape. And there's no mango, so like when we search for mango, not found. Okay? And we just display it in this format. I think it's correct. And now the additional function that we need. First is the sorting algorithm. I also try used to shell sort because in the my first sorting algorithm in assignment one is also this, but in this time I make them like two methods. One is for sort the word object and one for sort the strings. It means like when we sort neighbors, if we sort strings, they're different data types. So I write them in two different ways. And then the method that we use to extract the words from file. This is exactly the same as in the part one of the assignment. We use a split and a join to find the real word. Real word means word made of only letters, no numbers, no symbols. And we return the word list. Okay. And the display hash table method, like if there's no old word object, we first search it. If the word is not in the hash table, we insert it. If it already it exists in the hash table, we add frequency. Okay. Then the find neighbors method. In this assignment, I use the learns. I compare their learns to find out to find numbers. First, we create a dict to group words by their learns. Okay. If if the learns is not if not in it, we just append it. Okay. And this is used to compare words in each group. And these loops goes over all unique parts of the word in that group. Like if the two words are neighbors, I just make them pairs. If the pair of two words are neighbors, like each one is added to another's the neighbor set. Okay, they're neighbors of each other. And then write out profile method. This is exactly the same in assignment part one. Yeah, we use get all words to find all words, and we sort them and we write them. Okay, let's go. Here the build lexicon method. After writing all of the additional methods, this is really simple. First, give us an input file, like we find all words in it, and we made a instance of that object of the hash table class. We populate it, we find neighbors, we write it. Okay, let's run. And out, we can see that our out file from A to Z, correct order, frequency correct, neighbor list correct, and the order of the neighbors displayed are also correct. So I think we're right. Okay. And for the time, for the execution time is about 31 across two runs. Okay, now the skip list. And for this one, I create two separate class. One represents a single node in the skip list, and one in the skip list itself. And the skip list is a kind of data structure that it has several levels. The several level, which is also the bottom level, is just a regular sorted linked list of all elements. On the higher levels, there are sparse shortcuts that it can skip multiple elements. Like if we need to traverse it, it will be really fast. And each node may appear in one or more levels, and the number of levels a node span is randomly assigned when it is inserted. So the random is the key of the skip list. So we need random number, so we import random here. And for the skip list node class, here is the constructor. And for the forward pointer, I just make it a none first, and one for each level. This node will have a pointer to the next level. Okay. And for the skip list class, we set maxi level is 16. Maxi level means the maxi head that the node can have. And the probability I make it to 0.5. Okay. This is the probability that a node gets an additional level. Okay. And the constructor, the header, for the header, we create an instance of an object of the skip list node class. It's just a fake or virtual node that spans all levels and acts as the starting point. And initially we set level to 0. And here's this method, the random level method. It's just we generate a random level for a new node. And each additional level is added with probability of 0.5. And this ensures that the levels are higher, it is really difficult to get, really difficult to appear. Yeah. Okay. New node level to 0, while the random number smaller than this, and new node level smaller than max level, we add one of it. And then the insertion method. We need to use the update list, a new list, because it keeps track of where we drop down at each level, so we can later insert the node correctly. Okay. And then this loop is used to find insertion point at all levels. And then we store each position where we'll need to update pointers. Okay. And for this, if the next node's word object is already what we want, it's equal what we want, so we just add frequency of it. This is for avoid the duplicates. And then we create a new level LV here, just assign the random level to a new node. If it's higher than the current skip level, then we initialize the new top pointer to point to head. Okay, and at each level, we just need to link the new node between the proper nodes. And for the new node, we create a new instance of object of the skip list node using the word object and assign and the level we just assigned to this new node. Okay. And for the search method, the search is kind of like we start as top level and we drop down and until we get a level 0, then we check if the next node is a word just that we want. Okay, the current node is a header loop here. Okay, and until we get the first place forward pointer list index 0 means the first place means the bottom level 0. If it is what we want, then we just return the object. If we cannot find it, we return none. Okay, the get all word is just we collect all word object in sorted order by following 0. Like we make them in a word list. We return this. And the popular skip list is just like the popular hash table. It's really similar. If it exists exhausting, we add frequency. If not, insert it, create a new one of it. Okay? And then we write it. Then we build a lexicon. First off, uh, look at the file, find all words, make a class, and use populate skip list. And then find the neighbors and sort the neighbors. And then we write the file. Okay? That's wrong. We can see here from A to Y, correct order, good frequency. Like the neighbors are all displayed in the list correctly, and the order of neighbors are correctly, so I think we are right. And the average execution time of this is 0.0 across 2 runs. It's really fast. Uh, because actually the file here is really short, so it's really fast. Okay, so I think that's all. Like, thank you for listening and sorry for my high talking speed and bad pronunciation. Okay, see you.